Hi, I'm Mukesh. I've done a DBMS project, and as you could see, my title of the project, Carpool with a College Mate. So I'm a graduate student for the fall 2024. And okay, let's jump into my project. Okay, so here we are. The reason why this project is uh, transforming ride sharing from chaos to structure. So, as you know, the students at ITAMU are currently using WhatsApp, and that's how the riders post their trips, and as well as the driver post their trips. So, it's a two-way thing, and most often it's the rider, the driver who post the trips. And imagine a system where ride sharing depends entirely on a scattered messages. What could possibly go wrong? Ride details buried in unrelated chats, multiple students posting at the same time, conflicting information. So, just having this ride sharing pool WhatsApp group is not at all sufficient. And there are a lot of problems associated with it. So, basically, the information is unstructured. There is no way to track or record, and communication overload, no accountability. Uh, that's the current problem me and my college mate face. And there is more problem as well. And it takes so much time and effort to find a trip, match for a rider and a driver. So it takes a lot of time. So it's not an efficient way relying on WhatsApp. So as group admin, we are overwhelmed, and repeated queries and disputes happen. And as the student population grows, the chaos multiplies. Okay, I had an idea where I could utilize the knowledge that I have in DBMS and uh, implement for managing the carpool. And driver could post rides with the structured details, and riders could book rides transparently and track payments, and everything was logged and managed systematically. And here we are, a database driven carpool management system. And to be honest, this project is primarily focused on database, and um, without application level features like real-time notifications and integration with the payment. So all we are focused on this project is how the backend works and how we can create the structure on the background. So our primary goal is to design a robust database schema that supports user profiles for riders and drivers, ride scheduling, seat booking, and payment tracking. So, of course, the feedback collection and the review management. And it should be scalable and optimized for future growth. So, I've made a design in such a way that it can be grown. Okay. And assumptions made. So, as I said, there is no external thing, and there are certain things that are controlled on the application level, front end level, uh, and certain things on the back end level. So we are very much interested on the back end part, and that's where the core thing is happening. So, and DBMS plays a vital role in it. And all these things are entirely based on MySQL. Assume that this is entirely based on MySQL. And schema is designed as an independent DBMS for demonstration and education purpose. Yeah, absolutely. So the data may not be accurate, and all this are my own assumptions. And yeah, so Again, the primary focus is to get a normalized tables for efficiency and modular designs that can integrate and also goes well with the application layer. And I'm sorry, okay, data integrity. That means, you know, uh, there is no orphan records, and there are no confusion in the backends. There is no avoid errors as much as possible, and system errors. And if the population grows, our schema should be able to handle all those things. So, and prioritizing efficiency, data validation, and modularity over the interface concerns. Okay, so our focus primarily will be on the data validation and modularity. So, okay, what are we going to actually operate on, and what's the carpool actually is? So basically, here the driver posts about the trip. Okay, and he gives you information such as the start, destination, and departure time, and other stuffs. And let's see how it has been managed, going forward. And these are the basic simple steps: driver post trip, and the riders seeing on seeing this, book it and proceed to payment. So as simple as that. So it's not like a Ola or Uber where rider asks and asks for the driver. Here it's about the driver. Driver is the main part, and he posts about the trip, and people can join, and that way, things are much easier on the cost wise and also efficient wise, and it also helps you students as well, right? Okay, and okay, I will just give you an overview how I made this project. Okay. So let me go to the Excel sheet where I could show you how things pan out. So what these are the table. Okay, before going here, I will go by the project. Okay, so these are the basic things which I will be covering in the video. So as I said, the title of the project and the purpose of the project, and the operation scenario. Here we are. We'll jump into it. Jump into it. Yeah. So the students get registered on the application part first. Okay. Both the rider and the driver, and we have a student table in such a way that uh, I mean, this is only for students, right? So we collect primary key. We collect CWID, and that's the primary key, and it is ensured that it is only for the students. So this way, it has been like a filter, and yeah. So there are some unique things as well. So email ID and the license number pertaining to the drivers, everything should be in unique, and let's next about the posting trips. After this, um, the rider and driver comes into picture, and the driver posts the trip. Okay, when he's going to depart, and where he's heading to. All this information will be given by the driver and as a trip. Okay, and then it is open to the riders, who are of course students, uh, who can jump onto the trip and book. So, for example, there will be 3, 4 seats available for the trip. And when the booking happens, and there is one more catch, it's like one student can book for one, because we wanted to make sure that only students use it, and um, there is no what do you say, one student blocking all the seats. So those things doesn't have to happen. So we ensure that a student can book for one. So he cannot help students, or he cannot help friends who are not part of students. So that's where we have made sure that it is not possible. And at the DB level, we also, that can be done both in application and DB level. So what we are doing here is, um, at the DB level, the seat book, uh, okay, uh, seat booked cannot be more than the seat capacity. So that has been ensured, and the trigger happens. So trigger is maintained here, and that's how we ensure that DBs. Okay, what do you say? Adheres, no? And what else is important is about, yeah, only one student, one rider can book only one uh, booking and one seat. So here's the point. And of course, once the ride gets completed, payment will be tracked. And this is to give an idea for an administrator, for a college faculty or admin, to understand, okay, how much things are going to have to work. And also we can monitor a lot of other things. Okay, I have given an example workflow here. So it's like a driver registers and he posts a trip from this to this, and at some time, and the trip is saved in the system. 4 seats are available, and then a rider called Jane, he comes in, and he checks is there any uh, what do you say, rides to City Mall, and he finds this, and he books a seat, and now the seats reduced to 3. So that is maintained here. It can be done both at the application and the DB level, and we are doing at the DB level here. Mm, and then we monitor it, and we make sure that if and we, in the sense, the admin monitors it, and we can see what's happening on the whole picture. And the rider only can see what's put on the trip, and the driver just post about the trip. That's it. And next part would be, let me jump into the first point. So here we have covered the detailed operation scenario and about the English queries, and what is the reason why we are going to build. So we will need some information that can be pulled from the system and make sense out of it. So for example, so just give me how many people driving license are going to be expired soon. So who are actually driving, you know, driving, the drivers whose license are already expired can be found, and thereby the admin can maintain a lot of complaints, and he can ensure that things are going on track. And coming to the ER diagram, I'll jump into the workbench where I'm able to see you. So I'm able to explain you clearly. So here I've grouped in such a way that the students and student related data in core, and the transaction in here, and the rider information here. We have 3 tables and scheduling here. So uh, the way it has been designed is such a way that if there is any change in the major name or something, and it should be consistent, right? So if someone is someone is finding, oh, how many people are there in computer science, so what they will do is like they go I mean, type in find computer science, but some would have typed computer science with space with togetherness. So all those things happen. So in order to neglect all those things and make it consistent and uh, things like that, I have put an ID, and where you can get the list, so that there is no problem at the back end, when things is happening. So this is how it is maintained, and I'll just jump into how efficient it is. Yeah. So coming to the normalization, so it is designed and ensure that all it is up to 3NF is this is normalized. So there is no all the data is atomic, and there is no multiple data in single thing. So you can check the ER diagram with this. So, and you see, for a student, even the type and the major are put into a different table, and that is done in order to accommodate and ensure that it's completely normalized. Okay. And I just said all those things. So there is no repeating groups or arrays. Um, each table has a primary key, ensuring unique row. Yeah, each and every table has a unique key. And coming to the second normal form, uh, composite keys are completely avoided, and attributes like country name are moved to separate table. So you can see these things. Uh, so the country names are completely moved from to a separate table, and for example, the vehicle type ID, all these things are into separate table. So there is no confusion in each table, and it's been like broken down into pieces. And uh, and there's an interesting thing which I need to tell you. So that, see, we are also make sure that the data is not repeated in several times. So this location information, it can be used in the pickup location of the rider. So rider uses this as a pickup location, and when booking and scheduling, the same location is being utilized here. So see how efficient it is. The one single table is like used everywhere, and it's like, um, this is optimized to the core in such a way that we don't have to have a repeated thing. And at the same time, what do you say, we can just add the locations, locations, and all the locations are seen in one table. So whatever the pickup location or the destination, so all those locations can be seen on the one table. Yeah. So as we have broken down into a lot of things, uh, uh, the foreign keys, for example, let me give you an example. Okay. So here, we have ensured that bookings can be, we have a separate thing called booking ID, though that, apart from trip ID, rider ID, where they are being used as a foreign key in this booking. So as you could see from this table, the things are completely non-dependent to, and there is no dependency on each other, and it's very consistent, and it's ensured that um, it is maintained properly at the back end. So it's normalized, and there is, these relationship between attributes are handled through foreign keys, and thereby we ensure the normal form. And coming to the referential integrity. Okay. Um, so we ensure that there are a lot of other things when I said about the seats booked. So if there is a trip being cancelled or trip being removed from the database, how it is going to be affecting the other parts, and there is no often records left out. So these things are maintained at the DB level by using cascade updates and deletes. And also we have made sure that there are no null values uh, in primary keys, and the DB automatically points out, and it won't allow in the system as well. So the foreign key constraints. So I put all the things here. So as I said, on delete cascade and on delete cell null. So all these things are applied, and on the booking payment. So I'm sorry, and the parent-child relationship. So you could see the CWID in rider and driver references student, ensuring rider and drivers are valid students. So these things are completely maintained. So thereby the integrity is maintained. And unique identifiers, yes, we do have it. And as I said, null values For example, uh, there should not be null values in certain areas. For example, um, the CVID of the student, that should not be a null value. Okay. And these things are taken care at the DB level. How do I take care? Yes. So I go here and the bookings. So here I have put all the details and mentioned the primary keys and the cascade update and all the stuffs here. So yeah, so there are some tables where when you update one row of a table, it will be automatically updated in the other rows, and that is done using the foreign key and the primary key, and also the cascade update option. So, and if something is deleted from the database, it is also been maintained here clearly. So these are the things how it has been effectively defined, designed, and I just visualized using a DB diagram tool as well in order to get a overall view. And these are the data which I have used to insert as a sample thing. So I have taken, for example, the real data. I mean, not real data, close to real data. Uh, I've just maintained that the domain IDs and CW IDs, and made sure that the timestamp is clear. And I've taken considerable amount of thing and also executed. Probably next video I will try to I will explain you how things are getting executed and how it works. So I'll just explain how what this is, what my project is all about. Yeah. So I think I have covered the major portion. Let me jump into the index. Yeah. So I've talked about normalization. I've talked about the referential integrity, and I've shown you how we have taken steps to ensure it is healthy and designed properly. And in the next video, I will explain you. I will show you with the queries and running on the sample data which I have, and I will execute. I will talk about the English queries as well as the SQL queries. And yes, I think I have completed the entire slides. So yeah, so this way I have ensured that uh, an unstructured WhatsApp to DBMS, and I think DBMS helped me in this aspect. Thank you very much. Yeah.